binomial probability distribution. The binomial probability distribution, its mean and standard deviation, and we look at the interpretation of the probability values to determine whether events are significantly low or significantly high. So we are looking at binomial probability distribution.
Binomial experiment and PD properties. 1. N identical fixed number of trials, each repetition of the experiment. 2. Each has only 2 categories of outcomes. 3. Probability stays constant. 4. Independent trials. If a procedure satisfies these 4 requirements, the distribution of the random variable x is called a binomial probability distribution. It is the probability distribution for the number of successes in a sequence of Bernoulli trials.
First of all, PD short for probability distribution. We use BD short for binomial distribution. You are dealing with n identical repetition. For example, you toss a coin 5 times, 10 times, 20 times. There are 2 outcomes, heads, tails, yes, no, true, false. So that is really the main thing you want to pay attention when you're dealing with the binomial. And the probability from one stage to the next stage doesn't change. It is fixed, it is constant. And those are independent trials. If you look at rolling a single die, there are 6 outcomes, so it can't be a binomial distribution. However, if you're looking at the probability, you roll a die, the probability that the number is, let's say, odd or even. Now you have 2 outcomes. So it could be that although something has 6 outcomes, but you're really interested in making it into 2. So that is extremely important. If everything else works out, and most of the time they do, you want to pay attention whether this thing is working out or not. 2 outcomes. Now, as far as the notation is concerned, P is the probability of success. Q is 1 minus P, or the probability of failure. Make sure that the values of P and X refer to the same category called a success. X and P are consistent. X, a specific number of success in n trials. It's between 0 and n. Can it be 0? Yes. Can it be n? Yes, but it's nothing beyond it. P of X is the probability of getting exactly X successes among the n trials. For example, if you toss a coin, I don't know, 100 times, what is the probability of getting, let's say, heads 57 times? Just as an example. The formula that is used is at top here. P of X is Cnx p to the power of x q to the power of n minus x. I hope everybody remembers the shorthand notation. Cnx refers to n factorial over x factorial n minus x factorial. That is the combination.
The word success as used here is arbitrary and does not necessarily represent something good. Either of the 2 possible categories may be called a success S as long as its probability is identified as P.
It's important to understand success doesn't necessarily mean something positive. Success refers to what we are looking at. And whenever you're dealing with BD, and here's short for it, BD, short for binomial, you gotta be able to come up with N and P. Those are the parameters of binomial distribution.
Binomial coefficient, the number of outcomes containing exactly X successes. Each trial is known as a Bernoulli trial, named after Swiss mathematician Jacob Bernoulli. Notes: if the probability of X success in n trials is less than 0.05, it is considered unusual.
Again, the formula that I put up for you is being explained here, and as far as the terminology, Bernoulli trial, we simply call it a trial.
5% guideline for cumbersome calculations. When sampling without replacement and the sample size is no more than 5% of the size of a population, treat the selections as being independent, even though they are actually dependent. Warning: if we toss a coin 1,000 times, P times H minus 501, or any specific number of heads is very small. However, we expect P, at least 501 heads, to be high.
Let me just make sure everybody's following what's happening here. We've already discussed this 5% cumbersome or difficult calculation, which simply put means there may be cases, remember, when we do it with replacement, it becomes independent. but without replacement, it is no longer an independent event, it becomes dependent. However, you can refer back to previous lectures that if the size of a sample is very small compared to the size of a population, then we can assume independence. The other thing is that when you do the binomial distribution and you're looking at a specific number of heads or tails, for example, if you toss a coin 1,000 times, what is the probability of tails happening 10 times or 50 times, or heads happening the same manner? It may not be a huge number, but happening at least 501 times, it should be very high because we expect that to happen, sort of half and half when it comes to heads and tails. And now, what I want you to really pay attention to is the following. The probability of X is calculated as follows. Also, if we happen to look at the probability histogram for binomial distribution where P is 0.5, then we have a histogram which is symmetric. If it's less than 0.5, it ends up being right skewed, and you don't know that until you graph it and see it for a specific cases, and it's left skewed in the case of P larger than 0.5. What I want you to know is this formula and be comfortable with the concept. Capital P of X, this represents the probability of X successes, this one. But this P is the probability of success specifically for a specific case in general. So heads is always 50%. Again, for a fair coin. Tails, the same thing, 50%. That would be the case. Now, which one is probability of success? Well, depends on what we want. They happen to be the same. But even if it's not a fair coin, the probability of, let's say, heads is 60%, and therefore the probability of tails is 40%. Whatever that you're interested in getting, that would be referring to as the probability of success. The first one is the number of possible desired outcomes. That is a number that's a combination. And then the probability of a desired outcome. The first one is how many ways it can happen. And the next one, the probability of a specific one. And we add to it the following important formulas. The mean or the expected value mu is equal to n times p. For a binomial distribution, mu equals np. And variance sigma squared is npq. Normally, we are not interested in that. We calculate standard deviation, which is the square root of that. Needless to say, you really don't need Q to calculate it. Understand that's why when we look at the binomial distribution, we need N and P only given to us. We can calculate the value of Q. So that's why Q is not a parameter. It's something that we can easily calculate. It's important to distinguish between the two concepts. What is a parameter and what is not? Q we can calculate as long as we have P. These are the formulas that we are going to use in this section. Let's look at a couple of examples.
When an adult is randomly selected with replacement, there is a 0.85 probability that this person knows what Twitter is. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. A, does this procedure result in a binomial distribution? B, if this procedure does result in a binomial distribution, identify the values of N, X, P, and Q.
It's important to understand that it is selected with replacement and therefore they are independent. But even if it's not, if we are looking at the number, it's huge for the number of users. And so they can be treated as independent. That's the idea that was discussed previously. Now, basically, the most important question you want to ask yourself, how many outcomes? That's why if you look at the top right in blue, it is giving us the requirements for a BD binomial distribution. The most important thing would be to realize there are 2 categories. So there are 5 trials, n equals 5. There are 2 categories. The selected person knows what Twitter is or doesn't. The probability for each randomly selected adult, okay, in this case, we chose x equal 3. The p is 0.85, q is 0.15. They are independent, different adults. Verify that. I expect you to do the following. The moment you read that question, you should recognize, here's the given, because this is a word problem. So the given that you should recognize what you're dealing is, it's BD, short for binomial distribution. You should recognize it is, there are two outcomes. And if you are claiming this is binomial distribution, you should be able to come up with n quickly, 5 randomly selected adults. It doesn't matter, 3 of 5 or 2 of 5 or all of 5 or 1 of 5 or none of 5. How many do we have? N equals 5. The probability of success in this case refers to knowing Twitter. So that would be 0.85. I expect you to write this at the very least for your own to understand two things. Number one, you're dealing with the binomial distribution. And number two, you need to know two things, the parameters to know just about everything there is to know about binomial distribution. That's N and P. Now, you don't need to know, you don't need to be given Q. Q is 1 minus P. I can calculate. And then you look at the question, and now for x equals 3, you are going to do the calculation class. But again, I can't emphasize this enough. BD stands for binomial distribution. N is 5, P is 0.85. This is it, I'm done. This is my binomial distribution. I'm telling my reader, this is the distribution I have to deal with. Now to do the calculation, I need to know what's Q. I'm going to write it as 1 minus P and get there, and whatever X may be for the question. So N is 5, P is 0.85. Those are the information we need to begin with. Now X is 3, and Q is 1 minus P, or 0.15. These two, again, this can be calculated, and X is not a parameter. So having said that, let's calculate P of 3. Look at the very top formula, P of X. So I want you to pay attention to this one, the very top formula. We're going to replace the N with 5, and we're going to replace the X with 3. If we were to write the general form before even we move on to 3 specifically, we could write it as follows. Now, let me write it here. So we would write P of X is N factorial over 5 minus X factorial times X factorial. P 0.85 to the power of X. Q 0.15 to the power of N 500. So take a look at the formula. Now, why am I writing this formula? All you have to do, replace the X for whatever the case. There may be 4 or 5 different parts of the question you want to answer. You replace the X with the number that you want. For example, if we were to write the probability distribution for this guy, we would replace the X with 0, then 1, 2, 3, 4, 5, and calculate all 5.
Can we just use the combination if we don't want to use the factorial?
Sure, you can use a combination, but it is a combination. It is a combination of N, choose X. But I'm explaining the general formula for the binomial distribution for this specific case is what you see, and then replace the X accordingly, because you may have different parts where it's asking you, for example, when X is 3 or X is less than or equal to 2 or X is larger than or equal to 4. Do you follow what I'm saying? So this is a general case. Now, specifically for X equals 3, we plug in. And you're right, the first portion is just a simple combination. You do the math, you put it into a calculator, it does the job for you. I'm assuming nobody has any problem with the calculation of that. And it gives us the answer, which is 0.1382. So the probability that exactly 3 out of 5 randomly selected adults know what Twitter is about 0.1382. If we said at least 3 know, then the number will be much larger. Now, it is important that you understand the concepts, how it's calculated. I want to show you quickly how to use your calculator. So you can use a binomial distribution as follows. Second, vars or variables, then binomial PDF. You enter NPX, you click enter. If you enter n and p only, it gives you all probabilities from 0 to n. If you're using binomial CDF, gives some of the probabilities from 0 to x. So take a look at this one. If you put the binomial PDF 5, that's your n. 0.85, that's your p. 3, that's your x. It gives you the answer. So it can be calculated that way, but it is important that you know the concept. Depending on the TI that you have, 83 or 84 may be slightly different. This is from TI 84. For binomial PDF, you put the number of trials, you put the P, you put the X value, and you press at the end enter, and that will give you the results. Here's the next example.
Assume 1 out of 5 people has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 have visited a doctor last month. Find the probability that at most 2 have visited a doctor last month. Find the probability that at least 3 have visited a doctor last month.
I will look at other examples similar to this. I have left parts B and C for you to do. After we do more examples, you should have no problem with that. You're more than welcome to ask me if you have a question. It's very straightforward. Now, as far as this question is concerned, we either have visited the doctor or not. So again, it's important to recognize this is a binomial distribution. There are two outcomes, and we're dealing with different people, independent, and so on and so forth. The main thing is to recognize there are two outcomes. And if this is the case, then you must come up with n. 10 is the value of n. Remember, probability of success refers to what we are interested in calculating. It doesn't have to mean something positive. Okay, visiting a doctor, for example. You're dealing with a binomial distribution with n equals 10 and p equals 1/5. In part A, we want x to be 3. Now, we need to calculate q. Q by definition is 1 minus p, so that's an easy calculation. So you're dealing with a binomial distribution, n is 10, p is 1/5. Please understand, this is the part we need to know, and then we add other parts depending on the question. So for binomial distribution, you need the n, you need the p. I can't emphasize this enough. So in part A, x is given as 3, and we can calculate the q as 1 minus p, which is 4/5. And this is what I was explaining in the previous example. You write the formula in general. It's important to understand what happens. So for part A, or even any other part, you just write the p of x as follows. We keep it as x, 10 factorial, over x factorial times 10 minus x factorial, p, which is 1/5 to the power of x, times q, which is 4/5 to the power of 10 minus x. So all you have to do for part A, replace the x with number 3. If we replace the x with number 3, or you can use a calculator. Again, I want you to see the concept. It's important that be able to write the steps, and then at some point you use a calculator. Now you replace the x with 3, and it ends up being 0.20133. So the probability that exactly 3 had visited a doctor last month, according to this case, is about 20%, 0.20133. For part B, it says find the probability that at most 2. Let's write it. P of at most 2 means what? X is less than or equal to 2. At most. So I want you to understand the concept of at most. If it's at most 2, then you need to calculate probability of 0 plus probability of 1 plus probability of 2 by putting it in this formula, letting x be 0 and then 1 and 2 and add them up. That would be part B. So everybody can finish that. How about part C? Let's write it down. Probability of at least 3. That means probability of x larger than or equal to 3. We simply put, if we were to calculate it, would be P of 3 and then 4 all the way to n. You have to go all the way to n. However, probability of x larger than 3 is the same as 1 minus probability of x less than or equal to 2. And you've already done part B. So you really have to do subtraction. In other words, 1 minus part B. So all you have to do, calculate part B. And C is 1 minus that. By definition of at least and at most, you should be able to calculate this. So let's go to the next example.
A survey found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. Find the probability that at most 2 of them will have part-time jobs.
It's a BD, binomial distribution. How do we know that? We either have a part-time job or we don't. Yes or no. So, and of course, independency and consistency, all of the above. But the main thing is to understand n and 5. So, as we look at this portion, we should recognize we are dealing with BD. Therefore, n is 5, p is 30%, or 0.3. Now we follow the rest. We can write the general format, replace the n with 5, p with 0.3, calculate q as 1 minus 0.3 or 0.7. And so if we want at least 3, let's see what happens. Probability of at least 3, that means probability of x larger than or equal to 3. Therefore, you need to calculate x equals 3, 4, all the way to n. N happens to be fairly small, it's 5, so it's really not that big of a deal. In other words, you have to use this formula first. P of x is n factorial over x factorial times n 5 minus x factorial times p 0.3 to the power of x times q. Q is 1 minus 0.3. Q is 1 minus 0.3, which is 0.7 to the power of n 5 minus x. Now in this formula, you replace the x with numbers 3, 4, 5, and add them up. So this is for number 3. You have the general formula in blue. We plug in number 3. We come up with the answer. You plug in number 4. We come up with an answer. You plug in number 5. Needless to say, 0.7 to the power of 0 is 1. And now you have to add all those numbers. So add them up. And that's your answer for part A. So that's for at least 3. The next part is asking for at most 2. And at most 2, that means probability of x is less than or equal to 2. And you have to calculate the probability of x equals 0, x equals 1, x equals 2, and add them up. However, because at least 3 was already calculated, and we realize probability of x less than or equal to 2 is 1 minus probability of x larger than or equal to 3, we can use that one. So when we use that one, it's just a simple calculation, 1 minus the part A, and that's the answer. It can be done by technology, but you really need to understand the concept right, some parts, and then if you need to add technology to speed up the process. As an example, if you go to the top box, TI calculator binomial distribution, number 7 says if using binomial CDF gives some of the probabilities from 0 to x. Because we want x less than or equal to 2, we can write n, p, and x in that order, and it gives us an answer. Now, if you were to use the technology, in essence, you really have to use part B first, and then A would be 1 minus B. If you want to use the binomial CDF, just the way it is, for part A, it's 1 minus part B, because the way binomial CDF works, after n and p, you have to use x. What does that mean? it calculates the sum of all the probabilities from 2. But from what? From the beginning, from 0 to x. So if you want at most any number, it will do the job for you. Just put that number. But if you want at least, it doesn't do it. So you have to look at the complementary event to be able to handle it properly. If you're using the technology for part A, part B must be calculated first and understand we arrive at that, and then A is 1 minus that according to complementary events. Here's the next one.
It is reported that 2% of all American births result in twins. If a random sample of 8,000 births is taken, find the mean, variance, and standard deviation of the number of births that would result in twins. Use the range rule of thumb to find the values separating the numbers of twins that are significantly low or significantly high. And is the result of 200 twins and 8,000 births significantly high?
Before we do this question, it is the recognition of what type of probability distribution we are dealing with. It is reported that 2% of all American births result in twins. So that means either there is a twin or not, yes or no. There are precisely two outcomes. Okay, that's important to understand. So it is important to recognize it is a binomial distribution and why. And of course, we are assuming all independency and so forth. It's easy to assume independency. There are two outcomes. So you are going to write BD. And if you are claiming it's BD, you have to come up with N and P. So N is 8,000 and P is 0.02. And remember, it's considered the probability of success, whatever event we are interested in. And so we can calculate a mean, and they are not asking for anything else. So all we have to do, look up the formulas above and see what's mu and what's sigma. Mu is N times P. Sigma, it's N times P times Q, and take a root. Q is 1 minus 0.02 or 0.98. So Q is 1 minus 0.02. So mu is N times P. You multiply the two numbers, you come up with the answer. Sigma squared is the product of three pieces, N, P, and Q. And again, Q is 1 minus P. You come up with the answer. And now you need to take a root. Sigma is the root of that number is 12.522. So we got the mean, we got the variance, and we got the standard deviation. We got all of those. So that's part A, very straightforward. Mu equals NP, sigma equals square root of NPQ. Now the range rule of thumb simply puts as mu plus minus 2 sigma. So 160 plus minus 2 times 12.522. And so if we subtract 2 times sigma, we get 134.956. And if we add 2 times sigma, we get 185.044. That means anything less than 134.956 is unusual. Anything larger than 185.044 is unusual. So now that we have that, what about 200? Is it significantly high? According to part B, yes, it is, because it's larger than 185.044. That means 186 is unusual. Less than 134.956, that means 134 is unusual, okay? You can keep it with the decimals just to give, although the answer should be discrete, but I want you to understand. Even if it was, let's say, 134.1, that means 134 is unusual, okay? Although it's very close. And that's the idea behind this process. Let's look at one more example.
McDonald's has a 95% recognition rate. A special focus group consists of 12 randomly selected adults. A. Find the mean, variance, and standard deviation. B. Use the range rule of thumb to find the minimum and maximum usual number of people who would recognize McDonald's. C. Is the result of 12 people in a group of 12 recognizing the brand name of McDonald's unusual?
We are dealing with a binomial distribution. We have to be able to come up with N and P. In this case, you are dealing with a binomial distribution. N is 12, P is 0.95. Again, mu is N times P, 12 times 0.95. And To get the variance, sigma squared is n times p times q. Q is 1 minus p, or 1 minus 0.95, or 5%, or 0.05. And so we have mu, we have sigma squared. To get to sigma, we take a root, and we end up with 0.75498. Now, the next thing is finding, using the range rule of thumb, and finding where we stand as far as our unusual. Mu plus minus 2 sigma needs to be calculated. So that means 11.4 plus minus 2 times 0.754983, and we end up with 9.89 and 12.91. Meaning, in a case like this, if less than 9.89 people recognize the name, that's unusual. For example, if only 9. And larger than 12.91, for example, 13. Therefore, the answer to part C is, this is not unusual.